matter.
फिर सेठी साहब जब भी ग्रीन सिग्नल देते हैं, I will start the announcement and introduction part. Then we have the speakers with us, starting from Sethi Saab, who would give the genesis, how it all started. He would give a
Yes,
very
that's
nice,
casual,
a
yes.
good story will come out of him.
Yeah.
Then Sethi Saab ka partner, long-term partner, has
Tushar
been
is there.
Tushar Prabhu sir.
Yes, yes.
So we will listen from him also. Tushar Prabhu sir is a very accomplished, he owns his own magazine, that is Voice of Malabar Hills.
I can show it that. I want to copy.
So we'll hear his own experience with our mathematics club and how, he is highly resourceful gentleman. Then we shall listen from Shraddha Madam about fun with Olympiad maths. Fun with Olympiad maths. Then we will listen from Priyanka about issues with high school level mathematics learning and how she shaped her career in response to those issues. Then we will listen from Mr. Arjun something about higher mathematics, which he is very fond of. Some interesting aspects of college level mathematics. Then we will listen from Noori as to what she is expecting as a member of the club, new member. I will not be into mathematics completely, but what is she expecting as a young lady who is a mother of a 4-year-old child? So what is she expecting from the club? We can know from her. We will know from Sandesha Madam her interest in mathematics. She has been an accounts officer, a senior accounts officer in our department, but she has got a keen eye for mathematics. We will listen to her comments also. Then, as things go ahead, as Mr. Rajput has joined, Priyanka's daddy. Mr. Rajput has been computer engineer, a very senior officer, retired from BRC, and he has been into computer engineering. He was in computer division and he was one of the pioneering engineers for VSAT, satellite communication across the departments in atomic energy. That is Mr. L.S. Rajput. Then, so Jagtaran Sab, can we wait for one more minute?
Yeah, as you say.
Because by waiting for one more minute, we have Mr. Rajput who has entered.
Yeah. So now total number is how much? 9?
Abhi to 9. Yes.
Including ourselves.
Including everyone of us.
Yeah.
Yes. 9
So
people.
we can wait for the 10th member.
Yes.
Yeah. Because 9 is good number. But let's, as soon as 10th member enters, we can start.
Yes. Some people have informed in advance. For example, Rama Kanchiraju, who was to speak, actually in the afternoon he has got a class. Thinking our meeting would be in the morning, he agreed. But now our meeting has coincided with his class. Then another lady, Sujata, she is from Gurgaon. Her relatives have come. Their aeroplane got late. Their flight got delayed, so so the guests are continuing at home. She told at an appropriate time she will peep into the meeting.
That's bound to happen, last time you remember twice we tried.
Yes.
About I think 6-7 years ago, and we never got more than 6 people. Yeah, and sometimes different ones, not same also. Yeah. We
Then
two are
her
working together.
cousin,
Yeah.
Anuradha Malela, is Sujata's cousin.
Mm.
Today she has got a classical music program, some music
Mhm.
competition, etc.
Yeah.
Otherwise, she would have been very active.
Yeah. So anyhow, that next meeting we can have them. Yeah.
Yeah.
Okay.
Rajputji, would you like to say something? We are yet to start formally. In the meantime, you may please introduce more about yourself. Is more than what I'm aware of you. Mr. L.S. Rajput, as I mentioned, my close colleague in Bhabha Atomic Research Center. He has been the senior computer engineer at the time he retired.
Hello, Mr. Thyagaraju.
Yes, sir.
Now, are you?
You are audible but not visible. Now you are visible.
Now I am visible. Okay. Yeah. Hello. This is L.S. Rajput. I have I have worked in BRC and I know Mr. Thyagaraju since long time. And my field of interest is communication. And I have worked for the satellite communication for the DAE. And that was and I am interested in mostly in the computer related subjects, which always because I have seen the generations of the computers. So today's the stage of the computer, the computing that arena we have, and the whole world have. This is the all the efforts of the pioneers those have made in this field. And in BRC, we have got a supercomputing, the supercomputers, which is having a teraflop speed now. Otherwise, the gigaflop was the ultimate, say 5 or 10 years back. Now the speed, that computing speed is about teraflops. Flops. So I will be just a listener. Mathematics is it is fascinating subject. And yesterday, Mr. Tyagaraju has given the little insight what this group aim for, and I am interested because the present generation, the way of teaching of the mathematics, I think it is not so. Well, they find it doesn't find it so interesting. So we have to find the way where mathematics can be made interesting by sharing our experience and our skill. So I'll thank you all that I will be the just spectator initially. If I can contribute, I'll do that. Thank you, Mr. Tyagaraju,
Excellent.
for giving me the opportunity to introduce myself.
Thank you, sir. Nice to know you.
Yeah.
Nice. So, Sethi sir,
Yes, you
shall
can
we
start.
start now?
Yeah. Yeah. 9 is a good number, I think. Lucky
Yes.
number. lucky
Yes.
number for this year.
Mathematically, 9 is a
Yeah.
very special number.
Yeah, why? This year is also lucky number. 2025 adds up to 9.
Yeah.
Yeah.
Yes.
And I've written article, I think that might, our editor has to still to place it, maybe. How 2025 is very important in this century. This is the only square number of 45 square. The people can easily find it because it ends with 5, 25, and 20 means 4 into 5. So this art has been, done in SSC books also earlier, that the square is a square of 45. But earlier square 44 was in 1936. And next number is going to be next century. That 46 is going to be something like 22116 or something. I've not noted. I give it written for article, but yeah, it is not in this century. The only square number in this century is 2025. So that's a unique number, you can say, for this year. So uniqueness is that we should make our club also unique in some way. I wanted to name it also. Earlier, we were not named a club. We were just saying mathematics club. But I saw so many clubs are there. When you see your mobile thing, and I noticed when period we were doing online thing, I used to receive, see some problem and then give the solution and find 10 of them are giving, similar solution. And it is an international thing going on now. Maybe 2000 was a year declared internationally by UNO, I think UNICEF, UN, that educational body, as a international year for mathematics. So that time, lot of things were held, and all our people got together. We were doing some thing in Nehru Planetarium. That's why we are connected with it. That in the year 2000, I came across my friend Thyagaraju there only, and we were attending some program by director of that planetarium that time on mathematics, which was used by Einstein for the equation E equal to mc square. So we thought it's a very easy equation, and they'll do it very fast. But they took 4 months to do it. They were holding lecture once, and like on Sunday between 10 and 12 o'clock or something. Sometimes a little later also, just to find the solution of that equation and how that equation arrived at. So much mathematics was required. It was not only calculus and this undergraduate maths which was required. There's some tensor analysis and some other, subjects like we had to learn those terminology to arrive that. With the coordinate geometry, there were different methods it was arrived at using 4 or 5 branches of mathematics. Another I remember is vector analysis was not enough. We had to learn tensor analysis also. So finally we arrived at, this course started somewhere in July and ended in December like that. So during that period, I noticed there was a mathematics here, and we approached the director that time.
Professor Raval.
Huh?
Professor Raval.
Yeah, Dr. Raval, Dr. J.J. Raval. So he said, yes, I'm also mathematics background. Normally in astronomy, people come either from maths or physics to do it. So he said, I'm from purely mathematical background, and I do the research of, theoretically. I'm not an expert at practically seeing the stars and all, but we calculate theoretically how many moons Saturn must be having or Jupiter must be having, and so that type of. Then he knew from He had read my father and uncle's books, Sethi and Sethi, those days in 1950s or 60s. So he became friendly and he said, yes, you can do anything you like. Then I met you, Mr. Thyagaraju there, and we jointly decided the program should be for 3 days. And it was held, 9th, 8th, 9th, 10th December. But we made it afternoon, so that lunch is not required to be served to the invitees. So we used to start somewhere 2:30, 3 o'clock, and end at 6, 6:30. So that was a good experience. And later I noticed that with our late Prime Minister Manmohan Singh in 2000, around 2010 something, he said make this century of mathematics rather than keeping it only, because it became popular in schools and colleges. Then some clubs started doing work. So he wanted it to be extended in this century. So that I remember that we said we should continue doing such workshops or something about functions. Yeah. So what is the topic today I have to speak on is not fixed. I think I have to tell how we started thinking of making the club.
Yes.
So that was around 2013 or 14. I came across this newspaper of Voice of Malabar Hills. Thyagaraju?
Yes, yes.
Yeah, that show this paper that which is published by our editor. Yeah, yeah, yeah. Copy.
Here I have it.
So this is about 12 or 16 pages is coming through. Sometimes it's 12 pages.
Not
Earlier it started
yet.
with 4 and it was sometimes 8 pages.
I'll
And then
put it online.
editor will tell more about it. Nowadays it's usually 16 pages. Yeah, correct.
Voice of Malabar.
So this we receive every month towards the last week in now. Earlier it used to come in the middle of the month. Now it's coming around and the last week of the month. And that then I decided that why not approach the editor and do something about mathematics there. So I met Mr. Tushar Prabhu at his home. He offered tea and all, discussed with me for about an hour or so. And so then he gave me some 8 or 10 questions. I think it was 10 questions. That what do you think about it? He wanted me to see how I write the things on mathematics. That for publisher is important that how you write and present the things. When he gave those questions, so I took them seriously. And in a day or two, I went with a booklet of 20 questions, 10 questions in 25 pages. So I said that what you are given is a general question, but in detail, if I go, it will come like this. So he just wanted, short answers. You like, what you think, tell in 2 or 3 lines. So, so when we said, how can Apple publish so much? So he picked up some good lines from there, from each of those 1 or 2 lines and made an article which appeared first time. Then we started, he said he showed me that 1 or 2 newspapers, especially that from South, that paper, which is very popular. Yeah, so he said, questions like this. I said, those are interesting questions. We'll give our own. We can't, just see their pattern and do. So he said, yeah, make it interesting. So, well, so the most easy thing was magic square or such things, which people are not much aware of how to go about it. And so that he started publishing. Then I said, why not call a meeting and see that how many are interested and just know about it. So 2, 3 articles appeared. Then that response he got from some people, and that we had a meeting somewhere. He only arranged a venue, near Nana Chowk, there's that Gandhi shop, and above that, he said that place where my friend will allow you to do the meeting. And so once we did, and we thought that the timing was always a problem, whether keep in the morning or evening, and a few people will come, few cannot come. Even on Sundays, it depends on students are so busy sometimes near like in this month, they will not be able to come. Some teachers are busy with tuitions and all. So it was not working out. So I said 5, 6 people, so we can meet anywhere. So then Thyagaraju suggested, why not do it online? So this idea was that I said, okay, if that's the only possibility, for that they don't have to come and go, because traveling and other things, people are staying anywhere, and coming to particular place will take a lot of time traveling. So that is how the club thing idea started. Then our idea was to go to a few schools to spread, like we are saying, the problem of teaching mathematics is not proper. That we realize, but then we have to show. Even teachers, actually some people want to do something, but they are also think if they have knack of teaching but the time given to them to do the subject is very small. That even we notice in fifth standard, my granddaughter is there, they hardly give any time, and then there's a portion in the end, then students have to do themselves. That's why the reason the coaching classes have started and tuition work is going on. So not that teachers cannot, some are not able to teach because maths is not their subject. So at 5th to 8th standard, most of the teachers they're given are not mainly maths graduates. They have studied maths till 10th or something, so they will teach only that to that extent. So and same thing in SSC board, it was found that even the graduates which are teaching in high schools, they're not maths graduates. Most of them are chemistry graduates or biology graduates, even from science or from art side, maybe they are subjects like economics or history with that. So that's the reason the standard of mathematics in teaching is not very good. Another reason is the payment, the salaries they get is very poor according to what mathematics graduates can easily get in computers or in other fields, because there are very few mathematics graduates available. So even with graduates with first class are in demand. That you'll notice that if he's keen, if for teaching, they are easily taken. The problem is anyway. That problem is not only for maths; is the same thing for other subjects too.
Good one. A good analysis, Sethi Saab.
Yeah.
Actually, that's how our WhatsApp started. WhatsApp maths, our mathematics.
But our golden period was 2021 and 22.
Yes.
Because
Highest
that
amount
is when
of
actually
activity was there.
because of COVID, people are at home and they could do what they liked.
And
that is when this thing, worked.
The two most active people are now here.
Yes.
One is Shraddha Madam and one is Mr. Arjun.
Yes.
They have actually revived the Maths Club.
Yes.
Till then, Maths Club was very silent.
Yeah.
I really thank the members, in spite of the fact that there were no activities in the WhatsApp, not much communication, but still they remained in the group. So as a good gift, Shraddha Madam started putting a lot of questions, interesting mathematical
Yes,
questions.
she keeps on sending questions.
That's
so
how
that sometimes you would like to have a time you easily respond. Yes.
Now, shall we do like this, Sethi Sahab?
Yeah.
Now, in the revised scenario, in the current scenario, how shall we shape our objectives and how we shall go about? So, shall I share something about it?
Yes.
Yeah.
Yes, please.
The current scenario now, what has been proved is there are friends interested in mathematics. They silently read all the posts in the WhatsApp, but they may not come out and speak. They may not participate even in Zoom meetings. But then they are active internally. They read our posts.
Yeah,
They
passively.
enjoy it. They don't leave the WhatsApp group. That's a good thing about our group members. Am I right, Shraddha madam? They read, they enjoy, and they may not respond much.
Yes.
But still they are in the group. That's a good point. So from this, what it proves is there are people interested in mathematics. They are not bored with us. They are continuing in the group. Today, almost we have 70 members or even more than 70 members.
Yeah. Last 20 members you have added recently.
In last 2-3 days,
week
many
only.
more members got added. That's showing the interest. Around 3 years back, on one day we could get something like around 10 members added.
Yeah.
But between the last 2-3 days, we had 25 to 30 members added. That means the society is interested in mathematics. That's the proof. Now, in this revised condition of the society, we should have certain well-intended programs. For example, we'll pick up certain very interesting aspects of mathematics, which are of general interest, like something about interesting aspects of figures, triangles, then quadrilaterals, then polygons, some very interesting aspects we will pick up and we'll start posting that we call it as recreational mathematics. Recreation, just for fun. Recreational mathematics. Side by side, we shall add some posts which will be the example way of explaining certain concepts. For example, how to explain trigonometry in an interesting manner. If such methods are spread through our WhatsApp group, the members can teach their children. Indirectly, the children will be benefited. So, interesting methods of teaching is what we can contribute in the group. Then another thing is avenues for mathematics or the career opportunities for if people have to take mathematics seriously. So we shall request our members to post such ideas in the group. Then any more interesting things. But the best thing is we should have a physical conference also.
Yes.
Because there's nothing like it. There's nothing like a physical conference. Physically मिलते हैं, चाय पीते पीते बात करेंगे, उपमा खाते खाते. That fun is altogether different. So our Zoom meetings should lead to a conference.
Yes.
उसमें क्या है, जो Zoom में नहीं आ सकते हैं वो physical meeting में आते हैं. Because the joy is much better while meeting personally.
Right.
So our next target is actually after a few Zoom meetings, we shall have a physical conference. At least one day conference we should have over a lunch, tea breaks, etc. So these are the basic objectives and future activities. We will and the ultimate objective is to make Indians good thinkers. It is very far-fetched objective, but that has to be started. Somebody has to start. See, the mathematics club in India, in whole India, we must be having hundreds of mathematics clubs. We are only one among hundreds.
Yeah.
But all these 100 people to put together, the synergy created will actually contribute to the growth of the country itself. So indirectly, we are actually adding something to our country. This is the another aspect. So we will have to shape it well. We should make it more interesting, more purposeful. And one last point from my side is not only these objectives, I have one more objective, which can be added to Mathematics Club. Last around 1 year, uh, we have been running a philosophy WhatsApp group, almost 1 year, along with Sanskrit WhatsApp group and philosophy WhatsApp group, then Darshana WhatsApp group. We created these WhatsApp groups. In each WhatsApp group, there are at least 200 people in each WhatsApp group. So here the idea is philosophy is not simply about the God. Philosophy is basically about deep thinking. Systematic thinking is called philosophy. This is a new definition of philosophy.
Yeah.
Philosophy is not about Swarag Narak. No. It is not about bhakti or moksha, mukti. No. Our own rishis, they have defined philosophy as systematic way of looking at the things, holding a purposeful lens. Hence, they call it as darshana. Philosophy is called darshana by Indian rishis.
Is it the deductive or the deductive philosophy? Deductive word is used for that?
Yeah, means again in the thinking processes, they developed two methods. Our Indian rishis also developed these two methods. One is thinking by taking examples. In English, they call it inductive thinking.
Yeah.
Examples के साथ prove करना. For example, in a triangle, if you add all the three angles, it will be 180 degrees. How to prove it?
Yeah.
See, one way of proving is you draw a triangle, at random कुछ भी triangle draw कीजिए, एक random shape का, तीनों angles measure कीजिए protractor लेकर, तीनों angles जोड़ दीजिए. You may get 179 or 181 कुछ भी आएगा. Then दूसरा shape का और एक triangle draw कीजिए, फिर से angles measure कीजिए, then you add, you will again get approximately 180 degrees. Again with another shape you draw, like that for 10 triangles you take the measurements of angles and you add. In all 10, you will get approximately 180 degrees, 180 degrees, 180 degrees. That means practically by experience you have proved that three angles in a triangle put together, it becomes 180 degrees. This method is called inductive method. Now, without drawing and without using a protractor, just by mental logic, if you prove, like in 10th standard we have theorems, how theorems are proven. In that way, if you prove just on the paper without actually measuring the angles, that is called theoretical proof. So that is called deductive method. These inductive and deductive methods were also given by our rishis. So original logical thinking was all developed by our rishis. But later on, we remained there. Then the Europeans started developing above it, over and above. So that's how Aristotle, he started from our Darshana systems and he developed logic. Then afterwards, Aristotle's disciples, like that, till Charles Babbage, the knowledge continued and they developed a computer. Rajputji knows the history of computer development. So Charles Babbage was the person who had developed a physical computer, and Robert Boole, who developed the logic for computers. Oh, sir, Western countries may develop, lekin roots were from India. So this aspect we have to bring out into the maths club. How logical thinking is basically philosophy, and logical thinking may how mathematics can be a tool. So mathematics as a tool for thinking, this idea we need to develop. This will especially help the younger people like Priyanka, Noori and such people, because they can shine in their lives if they start using mathematics as a tool for their systematic thinking. And whatever be their job, but when they use mathematics as a tool for thinking, they really do wonders. So this component also we can add into our mathematics club. Now, I think whatever I wanted to share, I shared completely. Now I have no petrol to share. Everything is over. Now we will go to this Olympiad math. Something interesting. The Olympiad maths is highly recreational maths. There's one specialty in Olympiad maths. I'll share this specialty and leave it to Shraddha madam. This Olympiad maths actually creates mathematicians. Mathematicians को manufacture करने के लिए Olympiad maths has been introduced. That means Olympiad maths is supposed to be high level maths. Even within school, it is high level. Within school, also thinking methods are high level.
Yes.
Another aspect of Olympiad maths is simple ideas of mathematics are expressed very well. Those are so much interesting that those become recreational math. So let us request Shraddha madam to say something about Olympiad maths and to tell about herself also. How she teaches and what at all is Olympiad maths, सब कुछ आप थोड़ा बता दीजिए.
As I told you, like last time only, that I was very average student in my school days. I was very, very average. In fact, I did not understand math very well, honestly speaking. And in those days, like teachers used to scold us so much in front of everyone that you don't feel like asking only. And then it was the scenario. So in 10th grade also, I did not score much. Yeah, I got first class, but not that great. So when I got married very early, when I was only 19 years old. So I graduated after I got married. Then I wanted to do all, being in a Gujarati family, I wanted to do all my household work also, along with, I wanted to earn something and what. So then I started giving tuitions. So I'm actually from vernacular medium, like I had semi-English medium school. I mean, because I had all subjects in Gujarati except maths and science. So I really had to work very much, very hard. And I started giving tuitions, first to SSC level students, then CBSE, CSE. Then, of course, in between, I did B.Ed also. I studied B.Ed, I mean, and around 10, 12, 15 years ago, almost 15 years ago, I had I did that course of Cambridge International Diploma. So just to understand how these international schools are different, how these international schools are running. So that's how I started. And then when my son was in 10th grade, till my son was in 10th grade, I used to teach all subjects. And then later on, I just focused on science and maths. And right now, I have many students for Olympiad math. I not only have Indian students, but I have foreign students also. Because math is a subject where everywhere it is the same. So some NRIs are there. Like I have students from US also, Netherlands, Brussels. All my ex-students' kids are there. So that's how it is. And though you were telling that online is, I mean, I don't know, you stress more on physical, but I think now I am very much comfortable with online. Now I'll just show you something like, how I teach online. Should I share my screen?
Yeah,
Yes.
you have to become host.
Yeah, I have to send request.
Yes. Fine.
Yeah. I can. So this is how I write on my screen. And you were talking about, no, that triangle thing, some of the angles. So what I tell my students is like this. I mean, I show them like this. I tell them to take any piece of paper, make any triangle, random triangle, and then color them. And then I tell them to put all these three pieces here. All these three pieces. See, I tell them to cut it into three parts. And then you can put these three parts here. Sorry. This was red color. And now they all are in straight line. Correct? And what is the measure angle of a straight line?
180.
180 degree. So this is how I write on the screen and teach every concept. And so it is little easier because then I can reach many and I can reach those who are not in my area or in my vicinity. So that's how I'm just trying to do it.
Oh, very good. This is a third method.
Yeah. So it's a very practical method, no? So like that, there are so many methods, like so many different ways of teaching simple things. Of course, right now, I'm teaching Singapore Olympiad. I'm preparing my kids for Singapore Olympiad math, and it's really very tough. I keep on disturbing Arjun because I don't know I sometimes I don't understand those high level sums, but I do try my best. And my kids are doing good. Though I never won. I never got first rank, but my kids are. So that's how it is. And of course, it helps them to think a lot. In the younger age, when I'm right now, I'm working at the ground level. So I'm making at least their foundation strong. And they start thinking rationally, their logical reasoning side. They are problem solvers. They become problem solvers. They can take decisions very fast. Their decision-making power and all that thing, of course, definitely it improves. I can see the change, all kids, I can see the difference between kids who are appearing for these Olympiad exams. So their thinking is very different. So I have so many, I come across so different type of exams and different kind of sums. I can definitely put it on the group.
Yes.
Yeah. So that's how I can do what I can do.
This means what lesson we can learn? One lesson I learned, Shraddha madam.
What is that?
If you marry at the age less than 20, you become a creative teacher. If you marry at normal age, you will end up in becoming a school teacher, regular school teacher. Just for fun only.
No,
I don't mean it exactly.
No, and I can tell.
I compliment that you made best use of your talents.
No, nothing. But I can definitely say that every students can become a very good teacher.
This is a very interesting point.
Because
applies to me
we understand if a child says, I don't understand, I understand that he doesn't understand.
It's a very important point.
Because sometimes it is others feel it's very obvious that what is there to teach, but I understand them very well, their problems very well. So that's how it is. So I worked in school also for 2 years, and actually all school teachers are really working very hard. It's nothing like that they don't do it, but they have limited time. And they see school curriculum is based on such thing so that it should be understood by everyone, all those are intellectuals also, or some with the average IQ, they should also be able to do it. So school curriculum is based like that, made like that. So even teachers also, as sir told, that they are not well paid and all, but it's not like that in international schools and all. Nowadays the pay scales are very good. But the thing is, they don't get extra time to teach any topic in detail, in depth. So that's what I'm doing in my classes. So I try to get into, like, understand that I make them understand the topic thoroughly. So, and school teaching becomes like more like a mechanical and formula based. You
Yeah.
solve with this formula and the things are done.
Yeah, do it fast.
So that is that. Skill teachers are also working very hard, but they have their limitations.
So
Of course,
2
there should be
points
some changes. Something should be done to improve that.
Correct. So Shraddha Madam told 2 points. Just as a matter of summing up, I'm repeating those points. If in the school days, if we have been an average student, we become more than average good teacher. This is one very good point. Other thing is, as far as Olympiad maths is concerned, if we train the children in Olympiad maths, they do all subjects better.
Correct. That is
Many
true.
parents may say Olympiad maths का syllabus अलग है, school classroom का syllabus अलग है, क्यों सिखाना है? Though the syllabus is somewhat different, if they are trained for Olympiad maths, they do all subjects very well. Is it a
Correct.
good point, madam?
Yes, that is. So maths teach you, like, to become a problem solvers. You are not afraid of any problem now.
Exactly.
You come
Yeah.
across so many problems.
Excellent. Let us give a big hand to Shraddha.
Very good,
Is
Shraddha.
there
Very good. Very nice.
something from
Very nice.
Tushar Prabhu sir? Tushar Prabhu sir, we want to hear something from you.
Yeah. My name is Tushar Prabhu. I'm the editor of a monthly newspaper called The Voice of Malabar. It's a neighborhood newspaper. So that is how I got in touch with Mr. Jastaran Singh Sethi. He called me once, and he came and met me. And we started speaking about mathematics as such. And this was my first interaction, I think, of mathematics after college with someone. And, he was telling me that mathematics is such a day-to-day activities you require mathematics. Like you go to a grocery shop, you buy something, you calculate something. Everyday life you need mathematics so that no one fools you in money. And in sports you require, in cricket you require. That is how Mr. Sethi explained it to me. In this limited overs game, in this 2020 matches, there are five overs left. How much is 5 overs? 5 overs is 5, 6, 30. 30 balls, so many runs. In average, in an over, you need so many runs. So, if a sports player is good in mathematics, he can perform well. That will help him to perform well. That is how, Mr. Sethi brought that interest in me. And then I analyzed, after he went, I started analyzing that what Mr. Sethi said in my life. In my life, I remembered I was an average student like what Shraddha said. But I distinctly remember when I went to take my prelims, when I was in SSC, I went to the school to take my prelim papers from my class teacher. And my class teacher was one Mr. I remember his name, Salil Mohammad Chaudhary, and he was my English and history teacher. And he said, you have passed in all subjects, you will pass. But I'll tell you, Mr. Tushar, that if you want to score a first class, there are only now 18 or 19 days left for the exam. You practice mathematics. That is what an English and history teacher told me that time. And then I don't know why I listened to him. And then I came home, I told my mother. And the last 15 days before the exams, I was sent to a teacher in near Chowpatty. If you all remember, there was a very famous cricketer, Dilip Sardesai.
Yes.
His elder brother's wife, she was a mathematics teacher, and she used to teach at her home. So I used to go there every day in the morning to learn mathematics. And like my sir suggested, and everyone, when the results came out, I got a first class. And my highest score was in mathematics. I still remember the score 123, 123 on 150. So that was my, I think that was possible because one is that my sir told me that, and the second is I found a good teacher to teach me mathematics. And the same mathematics I continued in college. FIGC, I took mathematics, but I barely just passed out. But so in 12th standard, I changed it. I changed the optional subject to secretarial practice. And then I don't know for what, in the first year when I went, I switched over to mathematics. So I think that mathematics interest was there. And but first year college mathematics is a little different, it was a little difficult. And unfortunately, that same year my father expired. So, we had cut all extra expenses in the house. So, very quietly before the exams, I went and told my elder sister that I'm finding this very difficult, this mathematics. So she went and she got a friend who would, help me out with mathematics. And again, in first year BCom, I scored the highest in mathematics. So it all depends on the teacher. What Mr. Sethi and Mr. Thyagaraju always, say that it depends on the teacher how they teach, how they get the interest. Because natural interest of student is I don't want mathematics. So how they create the interest. And of course, nowadays, since a journalist, I make a lot of observations. And I see even my bhajiwala who comes here, he calculates the money on his mobile calculator. ये भाजी का कितना हो गया 15 रुपया, इसका 20 रुपया, he puts it on a calculator. And I tell him, अरे calculator का क्या जरूरत है तेरे को? Simple है, 4 भाजी लिए इतना, why don't you calculate by this thing? नहीं वो सर ये अच्छा गिरता है. A day, some days back I went to a pan wala, some guest were coming. We ordered some different pans and this thing. And he was doing his calculation on a calculator, sir. I'm not joking.
Yeah.
This is what he was doing on a calculator. And I remember panwalas never did that, or baniyas never did that. They always had something on their, the tip of the this thing. So I mean, generally, what I always speak to Mr. Sethi is that we need to educate people about mathematics, or there is something kind of practical mathematics, that we need to tell people and that interest that use this mathematics. And so that is what is required. And last thing I'll tell you, Mr. Thyagaraju, that I was into a business of printing, commercial printing business. I had a press in Ford. And and when you're in printing business paper, you get sheets, big sheets of paper. So whatever size paper you want for your product, you have to buy those big sheets and get it cut into your the size you require. So we used to buy these card papers whenever we had a big business card order that time. And I calculated, and they used to tell us that एक sheet के अंदर 72 visiting cards आते हैं. But because of my interest in mathematics, I sat one day, I dropped visiting paper. I said, ये थोड़ा 1 mm का ऊपर आधा mm का कम करेगा ना, तो तुमको 78 मिलेगा. और तुम मेरे लिए ये काटो, 78 काटो. So that guy, he did that, so I have to stand there and tell him all that. And then after 5-6 months, I met him on the road somewhere. I used to go to him regularly in his shop, and he met him on the road. He pulled me and he took me to a hotel. I said, "Tumko kya khane ka hai, khao." I said, "Kya ye sab? What is all this?" Then he told me, "Saab, मैं दिन का 1200 शीट कट कर, तो आपका जो आपने मेरे को ये जो बताया ना, वो साला मेरे को दिन में 6-7 हजार कार्ड ऐसा ही मिलता है उसका, on that 6,000 card, each 1,000 card, that box used to cost 300 rupees, 350 rupees. So he benefited from that, So this was this thing with mathematics. And I think what we should, Mr. Thagaraju and this thing, we spoke some days back. We all three of, Mr. Sethi, Thagaraju, and we decided that we'll do a conference or something. But see, three is a very small number that to do a conference or something. And Mr. Thagaraju also, he has this skill of, Mr. Sethi was saying that he has the skill of training school students, so that they can fare well in mathematics. That last minute, what I was told by my school teacher, what they can do so that they can score something. So we wanted to start that also. But see, three is a very small number. We need more participation from people, so that, we can take this forward. And I think mathematics should be made interesting. Yeah. That is all. Thank you.
Thanks. So very nice hearing from Tushar Prabhuji. He's our long-time partner for all our activities. And Sethi sir always says, Tushar Prabhu is the best partner for organizing anything. And, and we believe and we know that. And we shall all together do many wonders. Now our friend circle is increasing also. That's a good thing. Shall we listen to Mr. Arjun about what he has to say?
Yeah, hello. Hi, Arjun here. So I'm hello. Thank you so much for the opportunity, and it's always nice to keep coming back to mathematics. I'm currently a software developer, and I've been working for 4 years now. And before this, I've always wanted to get into mathematics academically, but um, very interesting nature of problems that you highlighted. I myself studied in IIT Kanpur, and over there, the education was never made fun or accessible. And I had a lot of personal issues of my own, but definitely the system never helped me so much. And I, really appreciate the purpose of this group in, uh, making it a good subject to learn. And mathematics, I still find very close to my heart as a subject. And I think uh, the career that I have, while it's not entirely directly in mathematics, it's a lot in logical reasoning and thinking. And these are very related, very closely related concepts, because the the kind of induction and deduction, and the kind of analysis that goes into mathematics, I think, is what really applies to my current field, and I'm very well placed in my life. So all that being said, I do miss dealing with more concrete mathematical concepts on a like piece of paper and a textbook. So I am really glad that I have the chance now to present on it. So I think without much further ado, I think I might have an unstable network. So while I'll share my screen and I'll turn my camera off, so that there's no disturbance. Okay, so I'm going to talk about Pascal's triangle today. All right, and I've always found this a fascinating subject, and I was able to. This was my favorite subject while studying mathematics, and it's the reason I wanted to study it a little bit further. Okay, so this is Pascal's triangle. Okay, this colorful one that you see. Um, right, so at the start you start with a 1. Okay, and what you basically keep doing is you create a little triangle. On each side of the triangle you just fill up ones, right? And you can see this little animation. You take two terms, and in the center of them, in the next row, you add the two terms and you get the next term. So 1 plus 1 is 2, 2 plus 1 is 3. Okay, this 2 plus this one will also be 3, right? And this one and this 3 make 4. This 3 and this 3 make 6, right? And this way you get this, beautiful triangle. And this, I mean, now you must be wondering, okay, what is this triangle? I mean, it just looks like a bunch of numbers. Well, this, to the people who know about it, they know this has a lot of really special properties, and I'm going to talk about a few of them in the coming slides. Okay, I made a very quick presentation for it. All right, so the first thing that you could kind of understand about it is binomial expansion. Okay, so what is binomial expansion? Bi refers to two, nomial means a polynomial, right? So a polynomial with two terms, a plus b, and then it's to some power, right? One, two, three. It could be what? So if you remember now, a plus b to the first power is a plus b. The famous equation we all studied in school, a plus b the whole square is a square plus 2ab plus b square, right? And now, if you do a plus b cube, if you remember a little later on in school, we learned a cube plus 3ab, a square b plus 3ab square plus b cube, right? And then this will go on and on. Now, here's the thing, right? So if you notice the coefficients, the number before the a and the b, everyone knows this is really 1a plus 1b, right? We just don't write it like that, right? So then the first row is this 1 1, right? The second row is this 1 2 1, right? The coefficients in the correct order, 1 3 3 1. And if we had a plus b to the 4, we would have a 1 4 6 4 1, in the coefficients. Now that's pretty crazy, right? So why is this the same? The answer is that because very simply, two adjacent terms end up adding coefficients during multiplication. All right. This is a very interesting coincidence, but the same logic by which we create the triangle is the same logic by which these coefficients come about. And I could do a quick derivation for you. So, like, you have a square plus 2ab plus b square, right? So you have, and then you multiply it with a plus b, and that's how you get the a plus b cubed, right? You take this, you multiply it with this, and then you get this, right? So a square, now the first one of course is very clear, right? You can only get one a cubed because there is only one a square here which will multiply with a single a, right? Excuse me, all this, right? And you have a 2ab over here, and you have a b square, but you need two a's to multiply with this one a to get an a cubed, right? Fairly simple. um for the next term, the 3ab square, this is where it gets interesting. You'll notice you need two a's and sorry, ab square, actually it should have been, my bad.
Arjun,
This
sorry to
term,
interrupt you. Arjun, we
yeah.
can't see your screen. I mean,
Oh,
I
you
can't
can't
see
see
your
that?
screen. I don't know.
Yeah, most of them.
Oh, I'm so sorry. Well, since when was it?
Only
Since
just
when did
now
it stop?
it flipped off. Just now. Earlier it was showing.
Okay, okay.
Now it has
Oh,
come
I'm
in.
so sorry. Yeah, yeah, yeah. So as I was saying, so you've got this over here, and then you're able to get this. Why does this happen? Maybe I'll try to do it a little more interactively for you. Okay, because so you have a square plus 2ab plus b square, right? You're multiplying it with another a plus b. Okay, and this is how it'll keep happening. Okay, so you're multiplying it with an a plus b. Now of course we know that there'll be only one a cubed, right? Because you need one a square over here, you need one a, you need three a's. Simply put, this has one a, this doesn't have any a's, this has two, and this would have to multiply with this one. That's how you'd get a cube. Similarly for b cube, because both these things are symmetrical in nature, right? A and b are really, we're adding them. There's no difference between a and b in the way you're getting the cube terms. Now for the central ones, the a square b one, okay, so how you get a square b? You get one a square b from here. You get one a square b from this and this. What ends up happening is, because these two terms have just one power apart in terms of the number of a's. Okay, you only have one a difference of one a and a difference of one b also. There's one b here. There's zero b's here, right? So yeah, and there's one a here. There's one b here. So a square b, right? From this and this, you get three a square b's, right? And the same way you get 3ab squares as well. Sorry, a square b, and then for ab square, again, the way the logic that I do is that I was looking at these two and multiplying with these two. Now I have to look at these two and multiply with these two, and I'll get the ab squared terms. All right, so as you can see, this this becomes a square b, right? And this, so basically, long story short, you'll get ab squared over here. Okay, so this and this would have given you this, and these two would give you all of this. All right, um so that's how, what you're doing is essentially the same thing. You're taking two of these numbers and adding them together to get the third number, right? You're taking two of these, adding them to get the third number. And that's exactly how this triangle works as well, right? You take two of these numbers, add them to get the third, if you remember that little animation, right? So that is how this triangle becomes the coefficients of any polynomial. So let's say you have um let's say you have a plus b raised to the n. Okay, so very, very simply, a plus, if you want to know, okay, a plus b raised to the n, you want to know, okay, what would it look like? Okay, so the first one, of course, everyone knows, it would be a to the n. Okay, now what would the second one be? Well, you know that there'll be one n over there, because if you look at this triangle, then the second term is really, whichever row we are on, right? This is the second row, third row, fourth row, or it might be n minus 1. But simply put, you just have to look at that row. Like, let's say I want a plus b to the 4. Okay, so the way I had a plus b square, I had to look at the second row. A plus b 4, I have to look at the fourth row. If I want to see a plus b to the 10, I could look at the 10th row, and these would be the coefficients, right? So a to the 10 plus 10, and that'd be 9, a to the 9 and a b, and then 45, a to the 8 and a b squared, and 120, and so on and so forth. So this makes it so simple for you to do a binomial expansion. Okay, this is just the first concept where this triangle, this beautiful triangle, ties in. Okay, the second place where it really ties in is NCR. All right, if this is about combinations, and what a combination is the number of ways we can choose r items from n items. All right, so this is the formula, and don't worry about it right now. Let's just understand how it comes around. Okay, so I'm going to give you a very, very quick simple example. Okay, let's say I have 7 different balls, okay, of different colors. Okay, now I want to just choose 4 balls at random. One, two, three, four. Okay, then how many different possibilities are there? Okay, if I'm choosing 4 balls, how many different? Well, a simple way to calculate it is, in the first spot I could get a red, I could get a green, I could get a blue, I could get a yellow, I could get any other color, I could get a purple, I don't know. Okay, so there are 7 possibilities, right? 7 possibilities for the first slot to be filled, right? Similarly, now, okay, let's say I filled in a red. Okay, I mean, you'll have to make some assumption over here, right? So I filled in a red. Now for the second slot, what could it possibly be? Now, given the red, it could only be green, blue, yellow, pink, whatever, purple, right? It whatever, all those 7 except for red. So there'd be only 6 over here, right? So that's fine. I know that, okay, there'll be only 6 over here. That's great. For the third slot, similarly, now I've gotten rid of 2 of my options, right? I So over here there'd only be 5, and over here, let's call this blue, right? And on this fourth one, maybe let's say we end up picking a yellow, but there could have been four colors to choose from. It could have been yellow, pink, black, and white. Let's say, okay, there would have been 4 options in the end. So the real number that we've come up now with, for the number of possibilities, is 7 times 6 times 5 times 4. Okay, because all of this multiplies, right? It could have been any one of these 7. It could have been any one of these 6. Could have been anyone. So you multiply all those numbers together, and that's how it's a pretty large number, right? But this is not the end of the story, because now if I choose red, green, blue, yellow, but what if the first color to come was blue, and the second was red, and the third was green, and the fourth was yellow? But in that case, I've picked the same 4 balls. I've just picked them in a different order. But I mean, what it doesn't matter what order I've picked them in. What matters is the fact that uh, is the colors of the balls in my hands, and I have the same 4 colors, right? So I now will have to divide. I'm counting the same thing, uh, way too many times. And how many more times am I counting? Well, that depends on a very simple concept. Okay, so there are these four. Okay, the number of times in which I can arrange these four, okay, is, let's figure that part out again. Okay, so we've got four of these. The first one could have been one of four. Okay, by the very same logic that we came up with over here, the first one could have been one of four, second could have been one of three, third could have been one of two, fourth one of one, right? So it's really 4 into 3 into 2 into 1, right? So it's 7. So that's the number we have to divide with, because we've counted this so many more extra times, right? Each one of these things has been counted 4, 3, 2, 1. What is the multiplication really quick? 12 times 2, 24, right? So this, let's just make this 24 really quick. So every RGBY or RGPY or RGQY, whatever it is, has been counted for all its arrangements, for all its orderings, and that has been done 24 times extra for each one of these. That's why we divide by 24, right? And that's how we really get this NCR formula. Okay, so a very quick shorthand notation we'll come up with. Okay, so n times 1 minus all the way till however many we have. Okay, divided by the rearrangements. Okay, let's call R the rearrangement. Okay, so so forget everything else. Just remember one thing. If you want to choose R times from n items, okay, R items, my bad. If you want to choose R items from n items, where rearrangements don't matter. Right now, if there could have been a situation in which it mattered that this came first, this came second, third, fourth. But in our case, it doesn't matter, right? We just have four balls in our hand. We don't remember which we picked first, right? So then we come up with NCR, right? So this is called a combination. All right. If the ordering did matter, it was called a permutation. Now, where all this ties in is the fact that is the fact that all these numbers are actually NCR numbers. So the so like let's say, how do we come up with this six? Six is the number of ways in, if we have um yeah, it's actually very beautiful the way it all ties together. This triangle could also be written as, I'll write it over here, okay, so that it's a little simpler. So the first one is one C1, then you get 2C0, 2C1, 2C2, and I'm going to explain all of this to you in a very quick second. Okay, so sorry, this was 1C0, 1C1. Once more. Okay, how many ways can you choose one item, zero items from one item? That's always one. The number of ways to choose zero items, given any number of, you have five chocolates. How do you choose zero chocolates? There's only one way. You don't do any choosing. And how many ways can you choose, one item from one item? There's only one way. You take that item, right? So that's why this is really the number of ways you choose this many items from this many items. Okay, so from two, if you're choosing zero items, there's only one way. If you're choosing one item from two items, there are two ways. You either pick the first or you pick the second, right? And 2C2 means you're choosing two items from two, and there's only one way to do that. You pick all of them, right? Which is why no matter how many items you have, if you're picking all of them, there's only one single way. You wrap your arms around everything and you take it to yourself. So that gives you this side being one, and there's only one way to pick nothing, this side, which is where you take, which is where you don't do anything, everything, you don't have anything, you're picking zero items, and everything in between comes from the triangle. Okay, and you can verify this for yourself. All right, so that's the beauty of this triangle. It not only tells you the binomial expansion coefficients, it also tells you how to choose a certain number of items from another certain number of items. Now, the interesting thing is, okay, why, it's so interesting. Why do these two things, why are these the same number? Well, the same, it can actually be explained as Mr. Thyagaraju was talking about deductions, right? You could of course go through the triangle and keep verifying that yes, this number if I do a plus b to the 3, then I get 1 3 3 1. This is 1 3 3 1. If I choose three items from if I choose one item from three, there are three ways to do it. If I choose two items from three, there are still three ways to do it. So then, yeah, you can inductively find the whole thing, but I'm going to just tell you very quickly how you can also do it deductively. Okay, so all right, so now let's say I'm expanding a plus b raised to 4. Okay, and this is where this is where the beauty of it really. So a plus b to the 4 is what you have: 4 times a plus b, a plus b, a plus b, right? A plus b, a plus b, and and really now, if I want to see how many a square b square terms there are, or let's say, yeah, let's say a square b square. Okay, what is the coefficient over here? How do I find that out? Well, I need to pick two a's and two b's, right? So basically, there are four rows. What am I doing? I'm choosing two A's and two B's. And if you remember, NCR is the way you choose R items from N items. Okay, so it could be either the first day and the second day, it could be the first day and the third day, it could be the first and fourth, second, fourth, third, second, third, fourth. So I will end up getting six items, right? There are only six ways in which I get two A's and two B's, right? It could be the first, and then they'll all end up adding up. This is when you're multiplying them, right? You're multiplying this row with this row and so on, and then you'll end up adding. So you end up getting six of these, which is why six is the answer over here, right? And if you just look at the table, right, over the triangle, then the number right in the center is 6, right? When you're doing a plus b to the 4, a to the 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b to the 4, right? So that's how this ends up tying in with that. Combinations and binomial expansions tend to tie in together, and this is the deductive reasoning for it, right? And then another interesting thing is that there are also successive powers of 2, and this would also tie into the binary world, which is also the world of computers, because of which we have this beautiful world around us in which we're able to systematically automatically generate so many things, right? We have successive powers of 2, and I'm going to explain this. So okay, let's say you flip one coin. What do you get? You can either get one of two outcomes, heads or tails. If you flip two coins, there are four outcomes. Wrong number written here. You get two heads, two tails, one head, one tail, one head, right? And then if you flip three coins, you basically double that, because after these two, there's a third area which could either be heads or tails, and then you have to, it could either be these four with the heads after them, or these four with the tails after them, right? So 4 plus 4, 8, right? And then if you flip n coins, you get 2 raised to n. Now why, how does this, what does this have to do with all this? Okay, you're going to find out. You're going to find out that, if you add all numbers, let's look at this triangle again. You add all the numbers in any row, you get a power of 2. So 2 raised to 0 is 1, 1 plus 1 is 2, 1 plus 2 plus 1 is 4, 1 plus 3 plus 1 is 8, right? And 1 plus 4 plus 6 plus 4 plus 1 is 16. We're going to find that out. So every row of these also adds to become a power of 2. Now, is this a coincidence? Is this crazy? I mean, we hear the word bi and binomial, and we also see the powers of 2. How are all these concepts tying together? Well, there's going to be a simple explanation for this, and it's going to be in this slide. All right. So now let's say we are flipping six coins. All right, or we're flipping one coin six times. Okay. Um, how many ways can we get three heads? So the first coin could give a heads or tails, second could give a heads or tails, third, fourth, fifth, sixth, right? So any three of these could be heads, and then the other three would automatically be tails. So out of six, to choose any three would be 6C3. This should be a 3 over here, right? And the reason this is a combination, okay, because these can't be rearranged, right? So it's not like it'll matter that the first is heads and the second is heads, because it can't be that second heads would be replaceable with the first. If it was an apple and an orange, okay, If I got an apple here and an orange here, then apple first orange later would look different from orange first apple later. So then there would be a rearrangement, right? But this is just a combination. We just have heads and tails. Okay, so that's how we get a 6C3. Now if we add all these together, what is 6C0? The way you get 0 heads out of 6 coin flips. 61 is the way you get 1 head. 62 is the way you get 2 heads, 3 heads, 4 heads, 5 heads, and 6 heads. Now, what is this? This is really, if 0 heads is 1 heads, 2 heads, 3 heads, you add all those, then that is the entirety of whatever can happen when you flip a coin 6 times. And what number of outcomes is there? 2 raised to 6. So that's how 6C0 plus 6C1 plus 6C2 all the way till 66 is 2 raised to 6, right? Because everything that's possible is covered, and we've just added all those on the left side and we got the same thing on the right side, right? So that also explains the successive powers of 2 logic. Powers of 11 now, yeah, if anybody knew the 11 times table, they would have looked at this and immediately and been able to tell, oh, the first one is 11, second is 121. These are powers of 11. 11 times 11 is 121. 11 cubed is 1331. 11 to the fourth is 14641, right? And this is also the same triangle that we use for triangles as well.
Good, good.
And these are powers of 11. So combinations and binomial expansion happen. I mean, this is the way mathematics works. We use what is called a base of 10, right? We have 9 digits, and then after the 10th digit, so whenever we're multiplying, we know that the second number that we're multiplying with will have, a zero after it, because we're choosing a base of 10, right? So when we're doing 11 times 11, what we're essentially doing is 11 plus 110, right? And then you're getting a 121, right? And a 121 times 11 is an 11 plus a, 220 plus another 110, and that's how we get a 1331. So what's really going on over here? We're doing this same thing that we did to come up with this triangle, right? Where we took the 11, right? We added it with another 11 essentially and kept a zero over here, right? And then we kept building on top of that, and we ended up getting the numbers that came ahead, right? So this is pretty much all that I would have liked to talk about. So there are far more properties of this triangle. Many of them are being discovered to this day. And if you notice that if we look at the rows a little bit slantedly, we this one of the these this is the Fibonacci series: 1, 3, 6, 10, 15, 21, right? And then this is built on top of the Fibonacci series, where you're adding the numbers of the Fibonacci series together, right? So it's to the next power. So this concept really goes further and further, but I just wanted to
Excellent,
Good,
Saraju.
good.
You have
I
given a
just
glimpse
wanted
of
to sort of share my
re-
love
yes.
and
It's a recreational maths using higher maths. Correct. Very interesting.
Yeah.
yes, thank you so much.
Thanks, Arjun.
Once what we will do is the same concept. We will have a special lecture where we can spend 1 hour time to very closely, step by step, understand the whole thing. Then
Yeah.
it will be very useful.
So many things are in one topic.
Excellent.
Yeah.
Shall we listen something from Priyanka? Priyanka, you are muted in audio also, video also. Priyanka, any problem?
She must have gone somewhere.
In the meantime, shall we listen to Nuri?
Yes,
Yeah,
Priyanka has come.
she's coming.
yes. So there is some power outrage actually, which is ongoing right now.
Oh,
So the network is coming and going. Okay. Okay, so to introduce myself, thank you, Uncle, for making me the part of this group. And as I've been listening to everyone around that what is a problem, what is being faced nowadays, and it is very clearly because during a very tender age when you are there in your high school, you have a lot of things to like get into place, get into like mindset that this is where this subject you are going to read ahead, this is what you're going to pursue ahead in your life, and so on and so forth. In a similar pattern, when I entered my high school, that was 8th or ninth standard, that time we started having bifurcation of subjects. So ultimately, you didn't had just one subject as science. You had biology, physics, chemistry, which came into picture in 9th, 10th. Then in maths, we had two books, which was Maths 1 and Maths 2. Maths 1 was metrics and other like subjects which were there into it, trigonometry and all these things, geometry and others. And part 2 had derivatives and integration. So for me, being a person who likes to understand the logic and then understand everything very thoroughly, that time having a very good teacher who can explain me the logic behind it was a tough thing for me. And during that time when we were in a position to make a like choice for our subjects, during that time I had my biology teacher whom I still remember, Shobha Ravindran teacher, that she was so much good with respect to teaching, in with respect to explaining things, the basic, that at 9th, 10th, I decided, okay, I have understood everything in biology, and biology is the subject from where I'll be making my career into. So eventually, I did my master's, my BSc, and everything in life sciences. And after that, I have gone ahead. I did my PGD in clinical research, and right now I'm working as a clinical data manager with with an MNC company. And still, like I was just thinking that okay, now my things with respect to maths are done, but no, being a data manager, we have a lot of biostats which comes into picture actually for us. So analyzing the data, getting in touch with the risk benefit ratio of the molecule what we are working on. So like maths is a daily integral part. Now for me, what I'm looking forward from this group is to understand like what actually made fall in love with biology by a proper guidance and everything. I'm just trying to understand that why maths was so hard during that time, and now I'm able to understand it, and I'm able to inculcate in my daily life. Okay, like if I'm going to purchase a sabzi, I know I need to do the calculation for the money. Then for my in my profession, when I'm like analyzing a drug and its results, it is like performing its risk benefit ratio. I'm using again maths into it. Like okay, these many subjects were there. These many subjects had an adverse event reaction. This didn't. So like it is my daily part, and just to understand how I can get into it in a much more proper way, this is what I'm expecting out from the group. That's it. Hmm.
Great. Excellent. What I appreciate you, Priyanka, I'm sure others also could catch your point.
Yeah, very nice.
You were able to identify your skill, and at high school level itself, you have set your target as to in which subject to take your career ahead.
Uncle, that happened because, as I mentioned, because of my teacher. Like,
Yeah,
she has developed so much interest for biology because, like, 9th, 10th, nothing was bifurcated, everything was at same place. But the way she explained the terms, the logic behind everything. So, actually, that made me take up biology actually as my
Yeah,
career.
it's
Hmm.
Good, good. And credit goes to your parents also. They
Yes,
did
very
not force you to
much.
take up engineering like 90% of parents in that place.
Yes, definitely. Like,
It's a
I still
21
remember, Uncle, when I completed my 12th. So I was having my discussion with Papa, and he asked me, "Ki, why don't you at least give the entrance exam?" I said, I know that I'm not able to do good into it. So why should I even think of taking a stress and going for the entrance exam when I know that I'm not able to continue it? And I won't be, even if I get into engineering, I would have gotten into it, but I wouldn't have been a good engineer. So there is no like point to it. So
One question I want to ask you: are you averse to mathematics, or you don't mind trying your hands on mathematics?
I don't mind trying my hands on mathematics
Okay,
because
if you don't mind trying your hands on mathematics, my dream for you is you do PhD in bio statistics.
okay.
Ah, this is the thing. Good.
Sure.
Shall we listen something from Ramnath Venkatesh? I either Mr. or Mrs. I'm not very sure. Ramnath Venkatesh. You may offer your comments.
Yes.
You may kindly unmute your audio and video. Ramnath Venkatesh. I would request all of you to unmute your audios and videos so that it will be very lively. Ramnath Venkatesh, are you available? Noori has gone because for Noori it is midnight now in UK. So Noori has left.
No,
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 no, no,
she's
I'm
there.
here. Yeah, I'm here.
Oh, Noori, you are here. Very good.
Yeah.
Please say something, Noori. Your own
Mm, yes, good
perception.
afternoon. Yeah, good afternoon, myself, Noori. Thank you for that. Actually, I am the part of your team, actually. Honestly, I like to this, just whatever I'm just hearing here. I like to this one. I have my daughter, she is a 4 years old. Right now, I'm working in finance department. Part time, I'm working in finance department. Part time, I'm working in customer services department. And I'm doing as a specialist in for the skin care specialist now, beautician as well. As a I did my graduation and I did my MBA in finance, but I'm not so much in maths actually. Was still about I was in childhood. Right now, my daughter, she is year 4, and she's the next year she's going for the grammar school preparation, and I am just teaching her so many. My husband is also working at HM Revenue. He's in IT firm, and he is struggling as a little bit maths, but not much me, because honestly, my maths is not good. I'm very poor in maths, and these classes, these meetings will be a give me a something is a tricky maths or something I can teach my daughters to some things if I am struggling, whatever is that. This is my motive.
Great. Responding to you, Noori,
Mm.
you have a 4-year-old kid. I will give one example what I did when my child was between 3 and 4 years. For example, numbers. Now, numbers, are these concrete or are these abstract? This is the question. Means numbers. So, do you call them concrete entities or do you call them abstract entities? The difference between the concrete and abstract is, suppose pen
Yes.
is there, pen is concrete. Now, anger is not concrete. How you will understand what is anger? By seeing several angry people, then you will understand what is anger. Correct? By examples, you will understand what is anger. If you see many happy people, then you will understand what is happiness. Correct? Whatever you can understand from examples, that is abstract entity. What entity you can understand without an example is a concrete entity. Okay? Suppose brick. You can easily know what is brick only by seeing one brick. You don't have to see several bricks. But to understand what is anger, you should see 3 or 4 angry people. Then only you can form an idea. Anger means like this. Now, numbers are abstract, not concrete. This is very interesting. Numbers are abstract. Then how I explained my child about numbers, I showed 3 fingers like this. So he has mentally, he has observed 3 are there. Then I put off the fan and I showed him the fan leaves. So fan blades also 3. I showed the fan blades and I told 3. Then I showed like this 3 fingers and I told 3. Then any 3 items I showed like this and I told him 3. From these 3 examples, he understood what is 3. Again, two things I showed examples, 2 like this and 2 bottles like this and everything 2. Then I told him 2. Then he understood what is 2 from the examples. So that's how numbers are abstract could be made understood to the children at that age itself. They will understand how to know what are abstract things. These are a few things. You will have more such examples to train your child in mathematical thinking. Good point. Then what we shall do is we shall go over to the next participant. Mr. Ramnath Venkatesh may kindly offer his comments.
Sir, good afternoon to all the participants.
Yes, sir.
Thank you so much, sir. I am a grandparent.
Oh.
I reside in Hyderabad.
Yes, sir.
And my grandson, Ayush Ritesh Prasad, is an avid student of mathematics. Today, he was elsewhere engaged in the sense there is an international informational Olympiad being held in the suburbs of Hyderabad. So his parents have taken him there. But I didn't want him to miss this opportunity. He is right now writing that exam, which will get over, I think, perhaps in the next half an hour or 45 minutes. So I was curious to know what today's program is all about. And I'm sure after hearing for the last half an hour, I'm sure this will be of enormous interest to him. And I look forward to the next date when you decide to hold this Zoom conversation. And I'm sure my grandson Ayush would definitely be interested in participating in the same. Thank you so much, sir. Thank you. Thank you, professors.
Then as far as when should be the next meeting, next Zoom meeting, I will leave it to Sethi, sir. Whichever date he suggests, we will have that. Maybe after exactly 1 month. I will anyway leave it to Sethi, sir. Then one Miss Surekha is there.
That's my daughter. I asked her, please, Surekha, please go ahead.
Yeah, please.
Hello, sir. My name is Surekha and I'm the mother of Ayush. I just joined the call sometime back. Ayush is writing the Informatica Olympiad right now. And I really enjoyed what you said, and I'm sure he will also learn lots from it. So I'll try to see that he attends the call next time for sure.
Yes. Excellent. Actually, I'm sure Ayush has excellent parentage and grandparentage. Quite brilliant people. Actually, we want to make this club interesting even to seniors, not only to students. The club should be made interesting to young professionals, students as well as seniors. Let us try and do the best in those lines. Then, yes, madam. Then, any last word? Now we are already. In fact, we have crossed our time. Any last comment from Sethi sir or any of the members?
Yeah.
Yes, Sethi sir.
Yes, should I? Yes, Thyagaraju?
Yeah.
Thyagu?
Yeah, please.
Yeah, I'm saying. Again, the next meeting could be, second Sunday of next month.
Second Sunday
Once a month, let's try to keep.
Yes.
So the first and third Sunday, Saturdays are working, and banks and other government organizations. So second Sunday can be a better choice.
So second Sunday.
Time you can fix, later.
Fine.
But second Sunday could be.
Yeah.
9th of March.
2:30 looks to be
Yeah.
safe because that this will be after lunch. It does not interfere with lunch.
Yeah.
Even ladies can also easily participate.
Because you're going to start 3 o'clock or something. Because lunch
After they
timing,
relax,
the
3 to
people
5
are
may be
different. You
ideal.
see,
5
our
may be
people
ideal.
eat late lunch.
Yes. After 5, they may go anywhere else.
Yeah,
2
3 to 5 is good time.
Yes.
3 to 4:30. Okay.
Yes.
Hmm.
So what shall we do? Shall we leave the meeting?
Yes.
Yes, sir.
Yeah.
Right.
Yes. I think this is a nice concept. Let's continue this for some time.
Yes.
And get more and more people interested.
Yes.
We should spread the link.
Yes, sir. Then, excellent. I think we shall make a report. I would request Priyanka to make a draft report of this meeting.
Sure, Uncle, I'll do that.
Then even 1 page will do.
Sure.
Then I would request Tushar Prabhuji to publish if he feels it is suitable for the paper.
Yes, definitely.
Yes. Fine. Thank you. Bye.
Thank you.
Bye-bye.
Thank you,
Bye.
Uncle. Thank you. Bye.
And all of us, Sadha Madam, Tushar Sir,
Yes. Bye.
Priyanka, Rajput ji.
Yeah. Nice meeting. Thank you.
Thank you all. Bye.
Okay.
Thank
Bye-bye.
you.